Okay, so welcome to another lecture of analog communication system. So yesterday we were done with this question, that is find the Fourier transform of this signal t, and this is f of t. And this signal is equal to e raised to power minus at u of t. And you have its value Fourier transform like this. F of t, its Fourier transform is 1 by a plus j omega. Done? We were done with this, right? Hello? 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 So, so we were done with this question. So Fourier transform of this signal was 1 divided by a plus j omega, right? Now I will write like this. So f of omega, that's Fourier transform of this signal, is 1 divided by a plus j omega. Rationalizing this, you will have a minus j omega divided by a minus j omega. Then what you will get a minus j omega divided by a plus b. A minus b is a square minus b square. J square is minus 1 minus or minus is plus, so it will be plus omega square, right? Done?
जी सर.
Please respond. So it's a divided by a square plus omega square plus j. It's not plus, it's rather minus. You write like this, minus j omega divided by a square plus omega square. So what you conclude from here, that you have some real part. This is the real part of Fourier series, and this one is its imaginary part. So you will write this f of omega is equal to f real of omega and plus j times f imaginary of omega. So f real from this equation is equal to a divided by a square plus omega square, and f imaginary of omega is equal to minus omega divided by a square plus omega square. Done? Hello?
Yes sir.
Okay. Now, in order to draw its spectrum, what you will write? So, wait a minute. Okay. So this is a real part of this for a series and this imaginary part. Now, first of all, I will try to draw the graph of magnitude spectrum. Magnitude spectrum. Magnitude spectrum will be f omega magnitude, simple. And this with versus omega. This is the first graph that you will draw. Now, can anybody tell me the value of magnitude of f of omega? What this is equal to? Because in general, if r is equal to a plus jb, then magnitude of r will be equal to a square plus b square, the whole root, right? Root of a square plus b square, right?
Yes, sir.
Okay. Similarly, now tell me the value of magnitude of f of omega, mod of f of omega. Can anybody tell me the value? Okay. Because f of omega is given here. F of omega is this. Tell me the value. Anybody? This will be f real square plus f imaginary square root of this. Now, f real is equal to what? A divided by a square plus omega square का whole square. F imaginary is minus omega divided by a square plus omega square का whole square. Now, this will be the root of this whole thing. Now, tell me this will be equal to a square divided by a square plus omega square का whole square, and this will be omega square divided by a square plus omega square का whole square root of this. Now this is equal to then a square plus omega square divided by a square plus omega square का whole square root of this. Right? Anybody having any confusion till now? Please tell me.
No, sir.
Okay, so now tell me final value of mod of f of omega, it will be equal to, because this is 1, this will cancel with this. Can I say this is 1 divided by root of a square plus omega square? This is the magnitude value of f of omega, right?
Yes, sir.
Okay. Now the graph of mod of f of omega with respect to omega is called as magnitude spectrum. So you just draw the graph of this. Equation is given, and from the equation, what you conclude. Now you draw the graph like this. This is omega, and this will be mod of f of omega. Now, first try put the value of omega equal to 0 when omega is equal to 0. Now tell me the value of mod of omega. When omega is equal to 0, what will be my mod f of omega value? Put the value of omega equal to 0. Tell me. Yes? 1 by a, right? Hello?
Yes, sir.
Yes, sir.
So when omega is 0, then what's the value of mod of f of omega? Tell me.
1/8.
1 by a. Right, exactly. Now, when omega tends towards infinity, positive infinity, tell me the value of mod of f of omega. What will be the value? 1 divided by a square plus infinity square, that's infinity. A square plus infinity is infinity, so 1 by infinity is 0, right? So you will get the 0 value. Are you getting me?
Yes, sir.
Similarly, when omega tends towards minus infinity, it will be mod of f of omega equal to 1 divided by a square plus minus omega infinity square. So this will be again infinity, and this whole thing will be equal to 0. That mod of f of omega
0.
will tend towards 0. So why, whether it's plus infinity or minus infinity, you will get this towards 0. So this will be the maximum value at 0, and then this will be like this. This will be symmetric. That means this will be in an even function. Omega, that is towards plus infinity, and this is towards minus infinity. So this is the magnitude spectrum of the signal shown in the figure. That's e raised power minus 80 u of t. Now tell me, is this signal, is this magnitude spectrum graph even or odd? But you can conclude from the graph.
Sir, even.
Even. What's the reason for that? Because f of minus omega is equal to f of omega. So you can conclude that this is an even function of omega. So magnitude spectrum, so I can conclude, so magnitude spectrum magnitude spectrum of simple f of t signal is even function of omega, is even function of omega. Now, in general, you can conclude magnitude spectrum of any real signal will be always even. Magnitude spectrum of a real signal will be always even. Now, can conclude the same from the phase spectrum. Let's see. Now, phase spectrum. Phase spectrum angle of phi will be equal to tan inverse of f imaginary omega divided by, tell me, f
Real.
real omega. So this is nothing, this is just tan inverse b by a. B is the imaginary part, a is the real part. So here b is equal to f in imaginary of omega subscript, that's f divided by f real of omega. Now can anybody tell me then the value of angle phi after putting the values of f imaginary and f real? So angle phi will be equal to tan inverse of, what's f imaginary equal to? Tell me.
Minus omega by a
Minus
square.
omega, well done, by a square plus omega square. So this divided by, this is
A by
a,
a square plus omega square.
well done. So can I say this and this cancels out? So you have tan inverse of minus omega by a. So
A.
this minus will be taken outside. So this is tan minus tan inverse of omega by a. So your phase value in this case will be equal to minus tan inverse of omega by a. So what will be its phase spectrum then? Phase spectrum is just the graph between angle phi and omega. So omega is this x-axis and this will be angle phi. Now tell me the value when omega is 0. What's angle phi equal to? When omega is 0, angle phi is equal to? Can anybody tell me? Angle phi is equal to minus tan inverse of 0 divided by a. So this is equal to minus tan inverse of 0, and tan inverse 0 is always equal to 0. So angle phi will
0.
be 0. Junaid is saying lately. This value will be equal to 0. When omega is equal to 0, your phase angle will be equal to 0. Well done. Now, when omega will tend towards infinity, second case you just, when omega tends towards infinity, now angle phi will be equal to minus tan inverse of infinity divided by a, that's infinity. So you can conclude this is equal to minus 90 because tan inverse Infinity is 90 or 1090 is infinity. So you have this angle phi is equal to minus 90, right? So you can say this is 0. Suppose this is minus 90. This is plus 90 degrees, dash, dash, dash. So, so this will be like this. This will tend towards infinity. This 90 as omega tends towards infinity. This will tend towards 90. Similarly, when you have omega equal to minus infinity, this will tend towards plus 90, like this. Are you getting me?
Yes, sir.
Okay, so this is nothing but your phase spectrum. Now, tell me, is phase spectrum even or odd? From this, what you can conclude? From this graph, what you conclude? Is this even or odd? Or you can say this is
Sir,
angle
even.
of omega is equal to this phi. Is this even or odd?
Sir, even.
No, this is odd. It's an odd function because this is not symmetric about the origin. If you reverse this omega axis, you will not get the same graph. So this is an odd function because f this this value angle f of omega is not equal to f of minus omega. Why? Because if you will reverse this graph about the origin, then you will get this graph like this. So this is angle f of minus omega. And then angle f of omega should be equal to f of minus omega. Then only you can say this is an even function of omega. Since this is not equal to angle f of omega is not equal to angle f of minus omega, so you can conclude this is an odd function, because if you will just put here as you will reverse this, you will put angle f of omega, then angle f of minus omega, then you will take minus angle minus of f of minus omega, then only you can say these two graphs are equal. So you can conclude that angle f of omega is equal to angle minus f of minus omega. So that is by definition odd signal. So this is an odd function of omega, right?
Yes, sir.
Anybody having any question, confusion? For this to be an even, this 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 should have been equal to this graph. But from the graph, you can conclude that these two graphs are not similar in shape, and hence this is not an even function. For odd, you have to proceed again by taking minus angle minus f of minus omega. So if you will take that from this graph, you can see this graph is angle f of minus omega. If you will take again minus in this graph, you will see this is like this graph. And this graph, that's 3, this 2, first. You can see that first and third are similar. That means this is an odd function of omega, right? So conclusion, important conclusion. So magnitude spectrum, please note down, is always magnitude spectrum is always even, and phase spectrum is always odd whenever f of t, that means time domain signal, is real valued signal, is a real valued signal. This is in general, always you have to remember. Magnitude spectrum or amplitude spectrum, you can say, is always even, and phase spectrum is always odd whenever you have f of t as real valued signal. Okay, so we are done with this question. Now, anybody having any doubt or any query, please tell me.
No, sir.
Okay, so we will continue with this question. This is your assignment, homework, you can say. So you just note down this question. Find the Fourier transform of the signal. You can say, let this be f1 of t given below. So signal is like this. This is positive t, this will be negative t, and this will tend towards 0 as t tends to infinity. So this value is 1, this is f1 of t. And this is equal to e raised power plus at u of minus t. This is your e raised power at u of minus t. This is a signal, and this is your homework, or you can say assignment. I will see it tomorrow, right? Just do it and tell me it's Fourier. What you will do, just find the Fourier transform. That means f of omega, f1 of t. Try to find its f1 of omega, then draw its magnitude spectrum and phase spectrum. These two you draw, and then conclude from this. Since this is a real valued signal, its magnitude spectrum must be this even, and phase spectrum must be odd, as we have already concluded from the above signal. Done?
Yes, sir.
Okay. So we have one more signal, because few basic signals, then we will start with the communication media. So one more signal. Just write down. Find the Fourier transform. Fourier transform of signal given below. Of the signal given below in the graph. What's the signal? This. This value is equal to 1. This is 0. This is minus 1. This is t. This signal is called as signum of t. This signal is your signum of t, right? Now tell me, is this even signal or odd signal? Is this signal even or odd? Anybody? Yes, roll number 8. Is this even signal or odd signal?
Sir, odd.
Odd. Well done. How? How can you conclude this is an odd signal?
सर अगर रिवर्स करेंगे तो फिर
By definition, signum of t is equal to signum of minus t. This is by the definition of an odd signal. So we will see how this is an odd signal, because you people are not getting this. So first of all, you just draw the graph of signum of t. Signum of t is this. This is -1, this is 1, this is t. Now, if you have to draw the graph of signum of minus t, what you will do? You are just reversing the x-axis and graph. So by reversing this, you will get this, right?
Yes, sir.
Okay, we have only few minutes left. Okay, we'll try to conclude at least this thing. This is -1, this is +1. So this is t. So is this equal to this? Signum of t equal to signum of minus t? Are they similar in shape? These two? This graph first and second? Are they similar in shape? Yes or no? Please tell me fast.
Yes, sir.
No, they are not similar in shape. So they are not equal. So this is not an even signal. Now, is this an odd or not? We will see. Now, from the second graph, you just put minus in case of amplitude, signum of minus t. That means plus axis, it will be converted plus amplitude, it will be converted to negative, negative will be converted to positive. So this
Okay.
negative will be converted to positive. You have this plus 1 and this negative, in case of this negative time axis, it will be converted to positive, will be converted to negative. So you have -1. So this is your minus signum of minus t. Can I say this first graph and third graph, are they equal?
Yes, sir.
Yes, so we can conclude that signum of t is equal to minus signum of minus t. So this is an odd signal. This is an odd signal, right? So now before going for the Fourier transform of this, you have to go for the Fourier transform of this signal. I will write down. We have one signal that is g of t is equal to f of t minus f of minus t. And this f of t is your this signal. F of t is this signal. This is your f of t. E raised power minus at u of t. This is your f of t. Since we cannot, because we're running out of time, this cannot be done in today's lecture. We will try to do this in tomorrow's lecture, but you just see f of t is this. Just subtract this from f of minus t, then tell me what is the value of g of t. This is also your assignment. Just tell me what is the value of g of t. I will just write down here. This f of minus t will be equal to f of minus t. It's equal to this. So this is your e raised power at u of minus t. This is your f of minus t, because you are just putting minus t everywhere. Minus and minus is plus, so this will be e raised power plus at and u of minus t. So these two you have to subtract. You have to subtract this f of t from this. After subtraction, you just tell me the value. So it will be something like this. So this will be your g of t. You just do this at home. So this will be your e raised power minus at u of t, and this will be your minus e raised power at u of minus t. From this, we can conclude, or we can deduct the Fourier transform of signum of t. Signum of t, because a reason being, because signum of t, area under that curve is infinity, so this is not properly defined. You cannot define the Fourier transform of any signal whose area under the curve is equal to infinity by using the mathematical definition. So you have to find the indirect means. Look here, this one,
Mm.
this
Yes, sir.
area under this is equal to what? It's infinity,
Infinite.
obviously. When area under this is infinity, so The signals whose area under the curve is equal to infinity, they are not defined properly by the mathematical definition of Fourier transform. So you have to find the indirect means. That means from some signal, so you have already, you can conclude from other signals the Fourier transform signal of t. So that's the reason this is called as limited defined Fourier transform, that we will study in tomorrow's lecture. Any question, confusion? Please do these things.
No.
I will see this. Copy पे होना चाहिए ये दो चीजें तुमने question, this second question and third one, this GFT. Any question, confusion, queries, do tell me. Okay, then we can wind up. Thank you.